Hello everybody, this is Udit Chaudhary. I'm presenting my Capstone project on analyzing NHA NES survey data. This is part of my delivery 2, which is a literature review. I researched three papers which are based on NHA NES data. The first one was the association between sleep duration and metabolic syndrome, which used the data from 2013 to 2014. The second was a prediction model for the peripheral arterial diseases using NHA NES data. The third was Tablets and Asthma in Children and Adults, which used data from 2007 to 2012. The first paper, which is the association between sleep duration and metabolic syndrome, aimed to assess the association of sleep with metabolic syndrome in the data from 2013 to 2014. The sample included 2,737 records from the 2013 and 14 NHNAS surveys. They conducted a cross-sectional study of metabolic syndrome and sleep duration. Metabolic syndrome was defined according to NCEP-ATP at third criteria. The metabolic syndrome severity score was calculated based on actual measurement of each component, and the data was adjusted for sex, race, and age. A generalized additive model, a GAM, was built to assess the smooth relationship between metabolic syndrome, its severity, and the duration of sleep. Adjustments for models were done for age, sex, race, and setting time. This graph is the result graph for the model, which presents a curve and also the sleep between sleep duration and metabolic syndrome prediction. The results were found to be the lowest risk of metabolic syndrome was observed in people sleeping 7 hours per night, and the lowest mean of metabolic syndrome severity was also observed for the same people. Short sleep duration was associated with higher risk of metabolic syndrome and higher scores of metabolic syndrome severity scores in men. The second paper, which is a prediction model for the peripheral arterial disease using NHA-NES data, this study aimed to build models for peripheral arterial diseases prediction and were used to validate two surveys were used to validate this data in the US general population. They used data from 1999 to 2002. Potential predicting variables were chosen like race, gender, age, smoking status, total cholesterol, body BMI, high density lipoprotein ratio, and ratio of TC to HDL, diabetes status, hypertension status, pulse pressure. Uh, the data was used to run multiple logistic regression methods for the prediction model construction. The final predictive variables were chosen based on likelihood ratio test. Model internal validation was done by bootstrap method. The 2003 to 2004 NHA-NES survey data was used for model external validation to see if the model holds for future data. Age, race, sex, pulse pressure, the ratio of TC to HDL, and smoking status was selected in the final prediction model. The odds ratio and confidence interval for age with 10 years increased with 2, where that of pulse pressure was 10 mmHg. These are all the stats for the results for this model, and the respective area under curve received the AUC curve. The final model was 0.2 and had good model calibrations. To some extent, this model had moderate usefulness for PAD risk prediction in general US population. The third paper was Tablets and Asthma in Children and Adults, which was conducted on data from 2007 to 2012. The study aimed to assess the direction and strength of the association between urinary phthalate metabolites and chronic asthma in children and adults. Data on 10 urinary phthalate metabolite self-reported questionnaire, spirometry measures, and covariates were obtained from 7,765 participants. Asthma was assessed using self-reported questionnaires for children and adults and via spirometry measures for. Out of the 10 metabolites, only monobenzyl phthalate was positively associated with the prevalence of self-reported asthma in children. No significant relationship was observed for adults. The association of monoethyl phthalate was modified by sex, which significantly increased odds of asthma among males. While no other phthalates showed a positive relationship with current asthma in males, monocarboxynyl nonyl phthalate (MCNP) was and mono,3-carboxypropyl phthalate (MCPP) were inversely associated with symmetrical defined asthma in adult females. The study found no clear association between exposure to phthalates and current asthma, except for a significant relationship between MBZP metabolites and self-reported asthma in children. As a result, exposure to phthalate and asthma development or exacerbation remains controversial, suggesting a need for a well-designed longitudinal study. These are the references and citations for all the three papers I used for my study. So, looking on these three papers, I find that the NHA-NES data has quite a bit of practicality and usability for healthcare data analysis. I would learn from the mistakes made in this datasets. For example, the asthma dataset, that they couldn't find much correlation between the phthalates and the presence of asthma in the US populace. I would try to redo their uh, models and see if I could make the predictions any better. I would also like to explore some other diseases from this dataset and hope I get good results. Uh, Thank you.